Or what? Or the probably should be the
Okay, a couple of you got this one wrong.
That's my way.
Okay, yeah, this one,
Is that the answer, 24?
okay, so I've got 24 volts, and then I've got 4 resistors. So 24 volts and 4 resistors. It's 90, so I've got 24 volts and 96 watts are my total. So somebody tell me, taking watts and volts, power and volts, what my current is. So power, 96 divided by 24. Somebody punch that in for me. 4? Okay, so it's 4 ohms. That's current, thank you. So I guess what I should have gone for, what I was really after was resistance, but I can still get it. So volts, divided.
It's the volts squared divided by power.
Okay, and you're right, and
Yeah, wait a minute, we did
but I can still do it in the triangle since I asked for
Power
current.
divided by volts.
Yeah, the current,
I can do volts divided by current will give me resistance.
yes.
So 4 into 24, what, 6? 6 ohms. This is the John, the one you were interested in.
Yeah, I see that. I got it right up.
So
You got it
actually,
right?
No, I circled down with the stuff and I thought it was him circling.
oh, did you get it right after all?
Yeah, I was more interested in 10.
Okay.
No,
But we can do this one because
Okay. Well, several people got this one wrong. So I've got all the totals here. I've got 4 resistors, and the combined, they're going to be 6 ohms. So this was the,
the total resistance in the parallel is lower than the.
yeah, so this is actually going to be lower than the lowest resistor.
But they're all legal.
They're all equal.
Right.
So somebody invert this, put this 1 over x for the 6 ohms.
0.16.
0.16666.
0.16 and then 6 and 6.
Yeah.
Okay, now these 4 added up equal that. If I were to do 1 over x for each of these, I'm going to get a decimal. And I can do just regular addition, subtraction. But this is my answer already. So if I were to do 1 over x, 1 over x, 1 over x, 1 over x, this is the answer I'm going to get.
Mhm.
So since this is the answer and there's 4 of them and they're all equal, I just have to divide that by 4. So what is my 4?
0.0416.
Okay, so that is each of one of these. Okay, so invert that again, and I'll get ohms.
24.
24 ohms. So if I were to work this from the beginning, if I were given 4 24 ohm resistors, but I didn't know the total resistance, it'd be 24x over 1, 24x over 1, and each time I did the x over 1, it would convert that 24 ohms to 0.0416. And then it's 0.0146 plus gives me 0.16666. And then I invert that, and I should get back to my 6 ohms. So it's just working the problem backwards. Okay, so you were interested in 10.
Yeah, because I got 50,000. And I did that problem a couple times.
Okay, 3 resistors are connected in parallel to 120 volts. Total current is, so this isn't, let me see, so all I have to do to use this one is I'm going to remove a resistor. I've got 120 volts. And the total current, that's total voltage and total current, and then 0.012 amps. Okay, so resistor 1 is so many ohms, so then we're looking for the resistance for R3. So we've got total current, total voltage, so we need total resistance. John, you have your total resistance?
Yeah.
120/0.01.
Yeah, you're gonna go
I've got
total current.
volts and current. So volts divided by current will give me how many ohms?
120 divided by 1012 is 10,000. 10,000.
7,000.
10.
10,000. 10,000 ohms. So that's a 1. Okay, so that's my total resistance. What do we have? So we know, let's see, 3 resistors are connected in parallel. Okay, so they're giving me the resistance for 2 of them. So I've got 20K and I've got 30K, and they want to know what the missing resistor is. Okay, so what we do is we take the 10,000 and invert it. Just tell me what that decimal is.
It's gonna be 0.0001.
Okay,
And then for the 20K, it's 0.00005.
okay,
And 30. 0.0000333.
was that 4 zeros?
Yep.
Okay, so now subtract those 2 from 0.001.
Minus. This is exactly what I did before. One, two, three. 0.0000167.
167? That was 4 zeros. So invert this one.
59. So I think what happened was I didn't go far enough out.
You still should have been fairly close.
I got 50,000, and I ran that number a couple times. And
You
now
got 50,000?
well, this one now I got
Yeah.
59,000.
Oh, right. 20,000, 30,000, 50,000.
Okay, and now what I would do when I'm all done is I do 20,000 x over 1 plus 30,000 x over 1 plus 59 x over
Yeah.
1, and I should come back with
That number.
10,000.
Yeah, you get the.
I got 50,000 for the last one, and it comes back to from what I remember, I think I got like 50,000 for the last one.
It's 59. It's almost 60,000.
Yeah, we're wrong.
That number inverted is 59,880.
That 10,000 is the lowest resistance parallel.
Okay.
I think what happened is we probably just missed out on a
Were
zero.
you guys
somewhere.
sitting next to each other? Because you can seem to have gotten the same. Okay, so you understand the concept. When you convert that to decimal, when you invert it, it's just standard addition subtraction.
I think my biggest issues is I just don't take the time to go back and double check
They're double
everything.
checking.
Yeah, but once you've gone through all this, it takes a fraction of the time to just go x over 1, x over 1 over x, 1 over x, 1 over x, and see if you came up with your starting number.
Couldn't you find the voltage for R2, because you have the amps and the ohms?
I could, you're
And then
right.
the voltage is the same, and then just do that math instead.
Yeah, the 120 volts,
That's another.
I didn't have the resistance though. I could have taken the total current, I could have figured the current and the current
That's exactly.
and subtracted it from the total current,
That's how
and
I
then
did.
used the current and the voltage to get resistance.
That's how I did.
It's only asking for the voltage of R3, it's the same as the voltage of all.
Okay, well, for number 10, it's asking for
Well,
the
I'm looking at the.
yeah, for 10, it's asking resistance, that's this one.
I lost you out there.
That was 2 to 3 hours. So that would make you say that.
Oh, yeah.
Did anyone have a concern with any other problems in On the, I think most everybody got the last answer.
They, you lose R2.
Oh, if you remove R2 from the circuit?
That was a bonus, right?
That was a series.
Was a bonus? It didn't say bonus, it's just straight points. So this one, this camera's kind of sorry. When this one goes away, the voltage, we figured the total voltage early on at 12 volts. That's not gonna change. That's the power supply. So if this resistor goes away, if it opens, the input's not gonna change. And then the resistors, or, again, these don't necessarily have to be resistors. They could be lights, they could be motors, they could be pumps, they could be almost anything other than a resistor. But if this one goes away, these won't change, they're physical components. And we already figured that if you did the grid, you should know all their resistances. So it's just a matter of all the resistances. And once, if the voltage, if this resistor goes away, the resistance is gonna change in the whole circuit.
Would the current stay the same?
No, the current will not, and you can see that here.
It would become the same everywhere.
Voltage, this voltage is not gonna change. So if resistance changes, this has to change.
Does this complete circuit change to a series at that point?
It does.
Okay, so then you add all the.
You just take, you add all the resistors that you figured out except R2, yeah.
Right.
That's what
R1, 3, 4, 5, 6.
Oh, one, that's right.
That's what
You gotta-
3415 is.
If it opens up, it turns into a series, and then the value you're given for what you have now is R4 is 2.5 milliamps, and if it all turns into a series.
Okay,
you
your
have that
milliamps, your current's gonna change. So you can't, these are physical components. So these will not change resistance. They are resistors, they have a resistive value. A resistor, it's a fixed resistance. So the only thing is if you change the voltage on a fixed resistance, if you increase voltage on a fixed resistance, the current will increase. If you reduce the voltage, the current will decrease. But we can't change the resistance because it's a fixed component. So these values, the watts and the amps, or not in the amps, those are gonna change because they're not a fixed part of the component. They're determined by these other two values. Current is determined by volts and resistance. And the resistance isn't gonna change because it's a component it's fixed in the component. If current changes, then the voltage would change. So so the voltage was a constant, we can't change that, that's our power supply. One resistor went away. So the other resistors remained the same, but the resistance changed overall. So once it became a series circuit, we added R1, 3, 4, 5, and 6, excluding 2. We had a new resistance total. And that new resistance with a fixed voltage, the resistance did change, but only because we removed a component.
It's only the total.
Yeah, and then the current is gonna change because the resistance changed and the voltage didn't change. So it's not a big deal. I mean, it's one problem out of many, so.
And we all got it right?
And most of, you know, I'd say half the class. And almost everybody, I was surprised, I almost got 100% through here. I think there was one or two people that gave me an odd value. I don't know who that is. If you're laughing, I didn't, so